Comparison testing of soldering irons. Some of the tests we use when evaluating soldering irons. Temperature overshoot and temperature stability. Is the temperature on a dial or a display the actual tip temperature? The soldering iron so that the thermocouple does not come loose during measurement. Here the PS900 power supply has just been turned on, and we are monitoring the tip temperature and the watts that the power supply is consuming. On the bottom you can see the tip temperature displayed in degrees centigrade. On top is a power meter displaying the number of watts that the power supply is consuming. When the unit was first turned on, the power consumed was 70 watts with a cold tip. As the temperature of the tip rises, the amount of power consumed is decreasing. When the tip comes to full heat of about 360 degrees, the power consumed will be 17 to 18 watts with no load on the tip. Here we see a conventional iron just after being turned on. The power supply for this iron has a temperature display. But if you watch carefully, the temperature read by the thermocouple is much higher than the temperature displayed by the power supply. Also note the power being consumed by this iron. It takes 200 watts to heat this tip to soldering temperature. The thermocouple temperature climbs over 410 degrees, while the temperature displayed by the power supply is about 350. The display temperature is not the actual temperature. The actual temperature can vary by many tens of degrees from the displayed temperature. This conventional iron suffers from severe temperature overshoot. The temperature displayed on the iron's power supply very quickly settles to within a couple of degrees of the temperature set by the operator. But the actual tip temperature can be up to 60 degrees higher than the display. This discrepancy between actual and displayed temperatures misleads the operator and can adversely affect temperature-sensitive components.